What is diffusion? Diffusion is a process where particles flow from a region of high concentration to a region of low concentration. What is diffusion current? Current that results from diffusion.
Now that we have gone over what diffusion is, we have set up an experiment to visually demonstrate what diffusion is using Skittles and warm water. As the food coloring comes off the Skittles, it diffuses out toward the untouched water. The food coloring is in a high concentration near the source, which is the Skittle. A similar phenomenon happens with electrons in a semiconductor. If electron concentration is greater on one side of the semiconductor, they will diffuse to the area with less electron concentration. Think of the food coloring particles as electrons. The movement of these particles generate a diffusion current. Wow, such a cool demonstration! Now let's go over diffusion current for holes and electrons. In this graph, the x-axis represents distance and the y-axis represents electron concentration. The blue arrow represents the electron flux and the yellow line represents the electron diffusion current density. The electron diffusion current density is in the opposing direction of the electron flux due to the charge of an electron being negative. The electron diffusion current density in one dimension is J sub n equals E times d sub n dn dx, where E is the charge on an electron, d sub n is the electron diffusion coefficient, which is in centimeters squared per second, and dn dx, which is the change in electron concentration over a set distance. A similar graph can be created for holes. In this graph, the x-axis represents distance and the y-axis represents hole concentration. The blue arrow represents the hole flux and the yellow line represents the hole diffusion current density. As you can see, the hole diffusion current density is in the same direction as the hole flux. This is because holes are positively charged particles. This is also why there is a negative sign in the hole diffusion current density equation. The hole diffusion current density is J sub p equals negative E times d sub p dp dx, where E is the charge of an electron, d sub p is the hole diffusion coefficient, which is in centimeters squared per second, and dp dx, which is the change in hole concentration over a set distance. Thus, these are diffusion current densities for both an electron and hole respectively. Both are directly proportional to the concentration gradient. Total current density is equal to E times n times mu sub n times E sub x plus E times p times mu sub p times E sub x plus E times d sub n dn dx minus E dp dp dx. The first two terms are contributed by the drift currents, while the last two terms are contributed by the diffusion currents, which we already have gone over earlier in this video.
To recap, diffusion is a lot of particles moving to an area of little particles. Diffusion current is the current that results from said movement. But don't forget, the charge from the electron is negative, so everything is backwards.
Behind the scenes. That's pretty gross, actually.